Hello, hello, and hello, my friend. Welcome to the Code with Reza channel. My name is Reza, and I'm here to teach you Python from scratch. This course is designed for those who have some programming knowledge and are familiar with basic programming concepts like variables, functions, and classes. It's not suitable for absolute beginners. So, I want you to sit back comfortably and enjoy the course. Let's get started. Python is a programming language which is very powerful, runs everywhere, is friendly, and easy to learn. For this course, we need two software. One of them is a Python software that you can easily download from the Python website, and the other one is an editor or IDE to write your code. I use PyCharm from JetBrains, but you can use any editor that you want. Now, after we go and download the Python software and run the Python software, we can see the Python editor. So let me show you how you can run it. If this is your command prompt, for example, I'm in Mac, you can say Python 3 and then you can run it. You are now in Python 3. For example, mine is 3.11.0. And you can use this is an interpreter, so it understands Python commands and can run it for you. We will use this for a couple of lessons. This command line works as a calculator too, so you can use some sort of calculation. In general, Python has two different data types, two different number types. One of them is integer and the other one is float. The integer is like 2, the float is like 2.5. These are two uh, types of numbers that Python supports. We can do a lot of things in this command line. For example, we can say 50 minus 5 multiplied by 6, and it answers shows the result. We can say 8 divided by 5. It's 1.6. It's fine to show the result as a float because it is really float. But the interesting thing is in Python, it always shows the float. Even if we multiply 4, divide 4 by 2, which the answer should be easy to, but it still shows as float. So the result of division is always float. If you want to get a result which is integer, you need to use double forward slash, something like this. And then it is integer. The another thing that we can use here is getting the reminder, which is like this, which is the reminder, which is 2. I think it's like all other languages, and if you have used calculator, it's always like this. Another interesting one is the power operator. For example, 5 to the power of 2, which is 25. It's also another interesting thing. Next, let's talk about variables. It's Python is like any other language that you can have variables and you can assign numbers to the variables. For example, let's say A is 20, or let's say B equals to 30. Oh, sorry, B equals to 30. So A is 20, B is 30. Now let's get the product of A multiplied by B, 600. Up to this point, it's very similar to other languages. For example, I use Java all the time and it's the same. But there is something which I really like in Python, which is like this. We can assign couple of values to couple of variables at the same time, like A, B, C equals to 1, 2, 3. It's very interesting. If you look at that, A is 1, B is 2, C is 3. It's really nice feature that you can do it in one line. You can assign a couple of different things in one line. If variable is not defined, like name, and you try to use it, it gives you error. It says name is not defined. One of the interesting things that again is very specific to Python is that there is a variable in Python, which is underscore, is a variable, and it holds the last printed expression that is assigned to the variable, to this variable. For example, look at here is 3. Why? Because the last printed expression was 3. For example, let's say a equals 12.5, b equals to 7, and now let's say a divided by b, this number. Now this number is stored into underscore. If I want to, for example, round this, I can say round the latest printed value to two decimal points, like this. So it's interesting. You don't need to type it again and again and again. This is for numbers. We only have integer and float, which is very easy. Now, let's move to strings. Strings in Python are enclosed in a single quote or double quote. So we can have something like Reza, my name, or we can have Reza. And like any other languages, like JavaScript, for example, if you have something like doesn't, you can put it into double quote so that you can easily show it. Because if you put it into single quote, it gets confused and throws an exception. But if you want to use this one, the single quote, you can again escape this one, like any other languages. So it works like this. And if you look at that, when you write something like, for example, my name, it shows a single quote here. So if you want to not show it, you can use the print function and say, oops, print, say Reza. It doesn't show that single quote anymore. So let me show you something interesting. We all know that there are certain special characters like new line. For example, if I say print, for example, I want to say Reza, my name, slash n, or backslash n, and then my surname Ahmadi. Okay. Now, if you want to print it, print Reza Ahmadi. Oh, I need to use the same thing here. It prints into two different rows because as soon as it gets the n, this is the special character, and it says, okay, let's go to the next page. But sometimes we need to have this backslash n, and we don't want the interpreter to interpret it as a special character. For example, look at this one. Look at this one. Let's say we want to print C backslash something backslash name. Okay. If I want to print this, I want to print name. But look at this, it breaks it. It breaks into something and AME because it interprets the backslash n as a new line. There is a way, if you want to stop the interpreter to interpret it in such a way, we just need to add R. So that looks at it as a raw string. So this is fine now. Another thing that in a string is interesting is sometimes we want to prevent end of line. For what I mean by prevent end of line is, look at this one. I want to say print with three quotes, single or double quotes. We can go to the next line. So let's say Reza Ahmadi, one, two, three, and I close it. Okay, this Reza Ahmadi. Hello, Ahmadi is in two different lines, which is totally fine. We can have even more than that. For example, we can say one, two, three, and we can say, "Hi, my name is Reza," and then we close it, and then we close that. So it means, "Hi, my name is Reza." But what if we don't want to do that? We want to print it in one line. So we can say, "Print one, two, three, hi," and then backslash my name is Reza, and then we close it. So in this case, it attaches all of them in one line. Sometimes you wanna in your code to put it in different lines, but when you print it, you wanna have it in one line. So this is how you can do that. Also, strings can be concatenated together. For example, these are all valid strings. We can say print Reza plus Ahmadi, which makes sense. We are passing this to the print and it says Reza Ahmadi. Another interesting thing, which is interesting for me, is we don't need that plus. We can say print Reza any number of spaces that we want and Ahmadi. In this case, it again concatenates this one. It's also interesting feature of Python. And also the third way that we can show it is Reza, comma Ahmadi, which the difference is it puts one space between them. In the previous one there is no space. Here there is a space. In general, we can have something like Python. And if you look at that, it adds all of them together. When we have two string next to each other without any operator, it concatenates it. Now we have reached to the interesting part. Look at this. Name equals Reza. That's not a strange name is Reza. But look at here, name 0, R. So it looks at a string as a sequence of characters. I remember that, for example, in Java, when you have a string like this, you cannot get indexed. It doesn't have any index. You need to change it to characters and get one of these letters like this. You cannot directly get it. There is a method for that, but not like this. So we can say name 1 E. It's very interesting. Now look at this. What if we have a very very large sentence like Reza Ahmadi is the best teacher, and we want to get the last item, the last character in this string. In Python, -1 refers to the end of the sequence, end of this list. So I can say name -1, which is R, this R. The one next to the R is minus 2. So it starts from minus 1. This is minus 1. Next is minus 2, minus 3. So I can say name minus 2, which is E, which is this E. So it's interesting. You can easily directly go to the. In so many other languages, you need to get the length of this and say name dot length dot minus one so that it pointer comes to this here. But in here, you just easily say minus one. That's very interesting. Now let's look at the slicing. We can do slicing too. For example, again, let's say name equals Reza. I can say name from 0 to 2, index 2, which is RE. Then the last one, the second one is exclusive. So it goes up to this one, not including this one. So this is 0, this is 1. It it throws away after 1. So it gets R and E, returns R E, name R E. I can say name 2 to 5. So it's 0, 1, 2. This is the first one, and 3, and there's no 5. So 4 or 5. 0, 1, 2, 3. There is no 5. So it's okay if you go out of this index. For example, I can say name, I can say name 0 to 50. It doesn't throw any exception. It just say Reza. Another interesting thing is we can, if we want to start from beginning, we can drop the first and say the last one. So when you drop this first part, means from beginning, like this. If you drop the next one, you means end of it. For example, 2 till end. And look at this one, it's interesting. Minus 2, start from minus 2 till end. So it starts from minus 1, minus 2, it goes to the end. Or if you want to get all of it, we can say nothing, colon, nothing means from beginning to the end. This is a very interesting way of getting a complete copy of that sequence. We have another function that we can use. That function is len, which returns the length of the string, which is 4 here. And there is another string str function. This function returns whatever we pass as a string. There is another method like integer that if we send a string, it returns integer. There is a float that if we send a pass a string, it returns. There are some other string methods which are very interesting. Look at this one, Reza Ahmadi. It's all lowercase. I say title. I call the title function. It makes the first letter uppercase. Look at this one. 1, 2, Reza, 1, 2. Strip removes the spaces on the left and right. We can also only remove on the left one or only removed from the right side. There is another method to change this one to uppercase, which is upper, and there is another one which makes it lowercase, like Reza dot lower. This is all lowercase. There is a method which checks to see if it ends with, for example, ZA. If Reza ends with ZA, which is true, there is another to find a index of something in a string, like find the index of EZ in Reza, which is 0 and then 1. The index is 1. And something very interesting is we can use EZ in Reza, and it checks, it's very interesting. It checks that if EZ is in this Reza. It's very interesting for me. True. For example, R in Reza. True. That's very interesting. Another one is uh, is another function on the strings. It checks if its string is digit. And also something which is interesting for me is in another languages, when we have couple of words together, we use camel case. But in here, we all of them are in lowercase, so it's like one word. It's interesting. Anyway, if this one is digit, we want to check if the input is all digit. Yes, it's true. We also have another one to see if this one is identifier. Is if this string that we pass is an acceptable identifier in Python, which is not one, which is not, is false. We cannot have identifier starts with number, but we can have one starting with character or letter. And we can have another, there is another method that checks if this one is lower, all lowercase. Yeah, it's true. But if we say if A, B, C, D is lower, it returns false. Same thing, we have is upper. Checks if it is uppercase. And there is a couple of more. The other one is, for example, imagine we have Reza Ahmadi and we want to remove a prefix. We say remove prefix Reza, removes prefix. Or we can have the same thing and let's say remove suffix. Removes the suffix. Another one which is interesting is 1, 2, 3, 4, 5, and we can replace space with comma. You can find it in other languages, so it's not something very weird or strange. Or we can say 1, 2, 3, split over comma. We have a list. This is a representation of the list. This breaks this using comma as a delimiter and returns a list of 1, 2, 3. And The last string one that I can show you is to check if something is starts with another couple of characters. For example, Reza Ahmadi starts with Reza. The real last one on a string is uh, this one. Let me show you. It's easier to show. For example, let me say I have name as Reza, and I say print. I want to say hello, that name. I want to say hello, whatever is in the name. I don't want to hard code it. I want to make it open to whatever is passed. It doesn't work. If I say hello name, it just shows hello name. So how to read this name value and put it in here? We need to use F at the beginning and outside of this quotation. F is for format. Format hello name, and it reads name and puts in here. Hello Reza. In Python, lists are mutable sequences. You can change them. This is how to define a list. First of all, let's start the Python software. Okay, so this is how we define a list. This is a list of 1, 2, and 3. You can say A equals 1, 2, 3. Or we can use the list method. List 1, 2, 3. Both of them are right. It is possible to nest lists. For example, let's say A equals 1, 2, 3, and B equals A, B, C. We can say C equals a list of A and B. Look at C, a list of lists. So this can be nested. Now a trick. Instead of creating a list like this, A, B, C, and something like this, we can easily do this. We can say A equals to list of A, B, C, D, E, F, G, whatever, and then we can close this. So look at A. Interesting, isn't it? Python is awesome. Now we have some sequences in Python, like strings, like lists. There are some common sequence operations that are common among all the sequences in Python. Let's talk about these operations. Let's say t equals 1, 2, 3, and s equals 4, 5, 6. Then we can test if 1 is inside t by 1 in t. Because 1 is inside t, it says true. Or we can say 4, which is not inside t, 4 not in t. Again, it's true because 4 is not in t. Something very interesting is if we want to combine these two lists, we can easily say t plus s. That's all. Now we have 1, 2, 3 from t and 4, 5, 6 from s. Very easy. We can also multiply a list by a number. We can say t multiplied by 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. Interesting. We can get an element from the list by its element by the element index, like t0 is 1. Or we can slice a list like t from 0 to 2. These two is exclusive, means it starts from 0 up to 2, but not including 2. So here we look for t index 1 and 2. So let's have a look. This is 1 and 2. Or we can access the last element in t by minus 1. As you know, minus 1 means the last element in the list. So this is 3 because t is 1 to 3. Now we can say from third element from the last of the list. So this is the minus 1, minus 2, and minus 3. So the third element from the last of the list till the end. T minus 3 and the end. It's 1, 2, 3. Or we can say the whole list from beginning to the end. We drop the beginning and we drop the end, and it goes from beginning to end. So it's 1, 2, 3. We can get the length of the list by using the function length. Length is 3. We can get minimum of t, of minimum of a list. The 1 is the minimum element in the list. We can get the maximum by using the maximum function. Maximum. We can find the index of the first element in the list by saying, for example, t dot index 3. It means look into the list t, find the first 3, and give us the index of that, which is 2, because this is t. 0, 1, 2. So the index of 3 is 2. We can count the number of an element in the list by saying in the list of t, count all elements that are 3. Here we have only 1. So this is 1. And an interesting operation here. We can test if two lists are equal very easily. Let's say this is A, 1, 2, 3. This is B, 1, 2, 3. And guess what? A equals to B. Test this as if these two lists are equal. Very interesting. Very interesting. I love this one. So, what do you think will happen if I change the order of one of the lists here? For example, this is A. Let's say B equals 3 to 1. Do you think these are equal or not? No, they are not. The reason is because lists are ordered in Python. So the order is important and the index of the elements are important in the list. These are all common sequence operations. Now let's look at mutable sequence operations. These operations are only applicable on mutable sequences, means the sequences that can be changed. Those that cannot be changed, we cannot do this. But for the sequences that can be changed, like list, we can use this. We can set the element at the specific index. For example, we can say t of 0 equals 6, 6, 6, 6. Look at t. We changed the element at 0 to 6, 6, 6. We can set couple of elements in one statement. For example, we can set the elements at index 3 and 4 to 8 and 9. Well, let's say t equals 1 to 7, 1, 2, 3, 4, 5, 6, 7. Now we can say t from 3 to 5 means two elements, element 3 and element 4, not 5. Let's make it 8 and 8. Both of them are 8. Look at t. Here, these two elements, 3 and 4, are 8. Or we can remove them. We can say t of 3 up to 5 equals empty list, means remove them. It's very interesting how we can easily remove an element from the list, a range of elements. Now look at t 8 and 8 are not there anymore. We can clear the list by replacing all the elements in the list with an empty list. So we can say T, all the elements in T from beginning to the end equals an empty list. So we removed all the elements. So look at T, T is empty. Now let's say T equals 1, 2, 3, 4, 5, 6, 6, 7, 8. We can delete one element from the list. We can say, for example, let's delete the index 1, which is 1. We can say delete T, the item at index 0, which is 1 here. Now look at T, 1 is not in the T anymore. It starts from 2. We can also delete more than one element. We can say delete T from the list tree from 3 to 5. Look at T, 0, 1, 2, 3, and for 5 and 6 should be removed. And if you look at here, 5 and 6 are not here. Or we can totally remove the list by saying delete T. So T doesn't exist anymore. Name T is not defined. Now look at this one. T equals 1, 2, 3, 4, 5. We can append to the end of the list by using the append method. T dot append 50. So look at the T at the end, 50 is here. We are appending to the end of the list. We can empty the list with two different ways. One of them is say T from beginning to end equals an empty list that we saw earlier, or we can call a clear method on the list. So T dot clear. We call the clear method on the list, and it makes the T empty. Now let's say T equals 1, 2, 3. We can copy the whole thing by saying T from beginning to end. It gives us a copy. Or by calling a copy method. We can say also copy. It also gives us a copy of T. We can insert an element into a specific index. We can say, okay, this is T, 1, 2, 3. We can say T dot insert into the element at index 0 with minus 10. Look at T. First element is now minus 10. We can get the last element from the list by using t.pop. This one removes the last element and returns to us. So t.pop returns 3, but the 3 is not in the list anymore. Look at T, it's only up to 2. We can also get an element from any specific index. For example, let's get this, let's pop this element at index 0, which is minus 10. So we can say T dot pop 0, minus 10. And if you look at the T, there is no minus 10 anymore. All right, let's go to sorting. Let's say T equals 3, 2, 1. We can easily sort this T by calling the sort method on T. Sorry, sort method on T. And look at T, it's now 1, 2, 3. Instead of 3, 2, 1, it's now 1, 2, 3. By using sort, we change the T list itself. So it sorts the T and stores in the T. So if we look at the T, T is also changed itself. But if we want to keep the T, only get a sorted list, but doesn't touch the T, there is another way. We can say again T equals 3 to 1. So T is 3 to 1, but I want to sort it without touching it. I will use the function which is called sorted, sorted T. So look, it returns a sorted list. But if I look at the T is exactly the same. T hasn't changed. Now let's say T equals 1, 2, 3. We can sort the T in reverse order. Reverse equals true. Look, T is 1 to 3, but it is sorted by reverse, like 3 to 1. Now let's use list as stacks. To add an item to the top of the stack, use append. So let's say a stack, we have a stack which is an empty list. We want to say stack dot append 1, stack dot append 2. And look at the stack. Okay, we add 1 and then 2. So we add to the top of the stack. To retrieve an item from the top of the stack, use pop. So this is the top of the stack. It's 2 here. So we say stack dot pop. So 2 comes out and the stack doesn't have 2 anymore. It is also possible to use a list as a queue. However, lists are not efficient for this purpose. Doing inserts or pops from the beginning of a list is slow because all of the other elements have to be shifted by one to the right or to the left. To implement queue, use collections.dq, which was designed to have fast appends and pops from both ends. This is how we do it. We need to first import it. For example, we say from collections import dq, and then what's the problem? Oh, import is not right. Okay. Now we are importing dq from collections module. Now we'll say q equals dq, q dot append 1, q dot append 2. Now look at q is of type dq, and there's 1 and 2. Now if we want to get this element from the right, we can say pop, like a stack. What if we want to get from the left side of the q? We can say pop left. So q dot pop left, which returns 1. Yes. Look at the q, there's no 1 anymore. Now let's go to an interesting topic. Python has a concept of list comprehension, in which we can create lists using complex statements. For example, I want to create a list from 0 to 9. I have to say A equals to a list 1, 2, 3, 4, 5, 6, 7, 8, 9. What if I want to create up to 100 or 1,000? It's not easy to do that. It's not efficient. So we can say A equals x for x in range 0 to 10. So we are saying range is a function which creates a sequence from 0 to 1 less than this. So 0 to 9. So it creates a sequence from 0 to 9. And we say we want all x's that are in this range. So look at A, it's 0 to 9. I can say 100. Look at A, it goes to 99. It's very interesting and powerful. Let's say we want to create a list of the squares of 0 to 9. So we'll say A equals, there is a range from 0 to 10, but what we want is x to the power of 2 for any x in range of 0 to 10. So we want any x in range of 0 to 10, which is 0 to 9, and we want to make the square of them. So look at the A. 0 becomes 0, 1 becomes 1, 2 becomes 4, 3 becomes 9, 4 becomes 16, and till the end. Or assume we have a list called WEC. WEC equals -4, -2, 0, 2, and 4. We can then create a list with the WEC values doubled. For example, I can say x, make it double, 4x in WEC. So it goes to WEC from here, gets element by element. For each element in WEC, it multiplies by 2. So let's look at A. -4 becomes -8, -2 becomes -4, and the rest. We can also filter the list to exclude the negative numbers. For example, we can say A equals to x for x in vec if x greater or equal to 0. So now for any x in vector, which is this one, it checks this condition. If x is greater or equal to 0, it shows that. So it removes the first two. Let's have a look at A. There's all positive numbers. And the last thing is we can call a method on each element here. So we can imagine we have a names list, which is Reza and James, and we want to capitalize the first letter. We can say A equals name.title for name in names. So what happens is names is this list. For each name, for each item in this list, we call it name. Call this method on top of the on that name. So let's see what happens. Reza and James, both of them are capitalized. Now let's talk about sets in Python. Python also includes a data type for sets. A set is an unordered collection with no duplicate elements. We can use curly braces or set function to create a set. Let me show you. First, we need to go into the Python software. Okay. We can say, for example, for creating a set, we can say basket equals curly braces. This is the symbol for set. We can say apple and orange. So our basket is a set which contains orange and apple. To create an empty set, you have to use set function. You cannot use curly braces. For example, A equals set. A is an empty set. This is how we create an empty set. Now look at the difference between creating a set with curly braces and a set with set method. Our A equals A, B, C, D. Look at A. It's one string, though there's only one element with a string in it, and only one element. Now let's create it with the set function. A equals set A, B, C, D. Look at A. It is a set of 4 different characters. So this is a difference between these two ways of creating the sets. Now let's create a duplicate, add a duplicate to a set and see what it happens. Look at our basket now. There is orange and apple. Now I want to create a basket. I want to add one apple, one orange, and another apple. Now look at the basket. Look, there's only one orange and one apple, so it removes the duplication. Only one element can be here from any type. I mean, not any type. I mean, one apple and one orange. Only one item, similar item can be here. No duplication. Now let's look at the operations defined on set. For example, assume we can say if orange is in basket. It's true. Or we can say A equals a set of A, B, C, D, and B equals a set of D, E, F, G. So if you look at these two sets, D is the same between two of them. One of them is A, B, C, D. The other one is D, E, F, G. So D is common element between these two. So by defining these two sets, this is A and this is B. Now let's find the letters in A but not in B. We can say A minus B. It here, A, B, C is here, but D is not here because D is also inside of the B. So we want the letters in A but not in B. So this is how we do that. So now let's find the letters in A or B or both. A or B or both. There are 7 elements here because D is similar between both of them. So we have only one is required. So there are 7 elements. Now letters in both A and B. B is the only letter which is in both A and B. Now letters in A or B, but not in both. For example, A, B. Look, D is not here because there is elements only in A or in B, but not in both. D is in both, so it doesn't show the D. We can find the length of the set with length function, 4. We can find the minimum element in the set, which is A. We can find maximum in a set, which is D. Or we can say A with numbers if it's easier. 1, 2, 3, 4, 5. And we can say mean of A 1 and max of A 5. Now look at below definition of a set. It is like list comprehensions that we talked about. So we can say A equals X for X in range 10. 10 means 0 to 10. When we drop the first one, argument to the range means from 0. And if you look at A is from 0 to 9. We can say B also equals X for X in range 10. This is B. They are the same. So we can check this one if these are the same. So, and it's true. The interesting point here is that sets are unordered. So the order of the element shouldn't be important. Let's test it. I will say A equals 1, 2, 3. Sorry, this is list. This is set. 1, 2, 3. And B equals 3 to 1. Are these two equal? Let's say. C. True, they are equal. So the order is not important. But in lists, the order are important. If I say A equals 1, 2, 3, and B equals 3 to 1, then these are not the same. False. Now let's talk about another data type, which is tuples, or some people say tuples. I will say tuple. Tuples are immutable sequences. Tuples are like lists, but are immutable. And it means once we define them, We cannot change them, but they are ordered. They are exactly like this, but the only difference is we cannot change them after we define them. Let's create some tuples. A equals 1, 2, 3, hello. This is a tuple. If you look at the tuple, it puts inside parentheses. So if you want to create any tuple, we can either put in the parentheses or don't put in parentheses. We can say r equals 1, 2, 3. It's a tuple. Or we can say r equals parentheses 1, 2, 3. Again, this is also a tuple. The way that we create an empty tuple is by just a parenthesis, set of parentheses. This is an empty tuple. If you want to have one element, we cannot say this because it's a number, it's an integer, it's not a tuple. If you look at a is 1. We should say 1, comma. We need to add comma at the end of it. Now a is a tuple. Or if you want to use a parenthesis, we should still use the comma at the end of 1. So a is tuple. If you don't add comma at the end, it will be something like this. This is just a number. So we need to add comma so that it becomes a tuple. For creating, this is tuple for with one element. For creating a tuple with more than one element, we don't need to add the comma at the end of the tuple. For example, for one element, we say 1, comma. But for more than one, we can say just 1, 2, 3. We don't need to put comma at the end. We don't need it. It works like this. Or in the parentheses, you can say 1, 2, 3. No comma at the end. It works. Or we can use a tuple function, or yeah, it's better to say function now, which gets a list and creates a tuple from that. Yes. Tuples can be nested. For example, A equals 1, 2, 3, B equals 4, 5, 6, and C equals A and B. So we can see it's a tuple of tuples. Please note that tuples are immutable, so we cannot assign the value to a tuple or remove a value from a tuple. We don't have delete command here. We cannot change a tuple, for example, to on index 0 to 13 or things like that. So all the operations that manipulates, edits, removes, deletes, adds, appends, none of them work in here because we cannot change anything. Now let's see something interesting. This is one of the features that I really like about Python. Let's create a tuple with 1, 2, 3, a t. It's 1, 2, 3. Now look at this statement. It's very interesting. A, B, C. We assign it to t. So what is happening? This goes and extracts the t, or says the term is unpacking. It unpacks the t and extracts the 1, 2, and 3 and assigns it to the A and B and C. So look at A, 1, B, 2, C, 3. This is called sequence unpacking, and it's very interesting. Very interesting. All the common sequence operations are also applicable to tuples. I have already talked about these operations in the list video. I think this is the second video of this series. Please refer to that for a complete review, but I'm going through them here very quickly. So assume we have below two tuples, t equals 1, 2, 3, and s equals 4, 5, 6. All these below operations are possible with the tuples. For example, you can say 1 in t, in 1 in t. We can say t plus s, add this one together. T multiplied by 2, accessing an element 0, for example, or any element from t. Because it is ordered, we can access that. Or t from 0 to 2. Or the last element in the t. Or the elements from the last 3 to the end of it. Or a copy of all of it. Exactly like what we talked about in list. And we can use len min max, like len t mean, the minimum number, max, the maximum number, and the index of number 3 in the tuple, which is 2 here. Index is 2, 0, 1, 2. And dot the count, how many number 3 we have here in the tuple. T dot count. We have only one. You can also sort it using the sorted function or sorted reversed. Sorted t comma reverse equals true. This is reverse. Another useful data type built into Python is the dictionary. It is best to think of a dictionary as a set of key value pairs with the requirement that the keys are unique. A pair of braces creates an empty dictionary. So let's create an empty dictionary. Let's say users equals, so users is an empty dictionary. So if you remember, this one was for lists, this one was for tuples, and now it is for dictionary. Uh, Sets also use this one. So let's assume we have users defined as Reza active and Sam active. If you look at this one, you can see that Reza is a key, active is value, Sam is key, inactive is value. So we have two items here, two key value pairs here. Now let's look at users. This is a dictionary with two items in it. Now let's get the value which is stored for Reza. We can say, okay, we have users, we have the key which is Reza, we pass the key here, and it gives us the value for the key Reza, which is active. This here. We can add to the dictionary like this. We can say users Ali, it's a new key, equals active. Now look at users, Reza, Sam, and Ali at the end. So we can, by using this notation, this statement, we can add to our users dictionary. The interesting thing is, if Ali already exists, this will update the value for Ali. But if Ali doesn't exist, then it creates a new item and puts it to the dictionary. So let's update the dictionary. It's the same as above. For example, Ali equals inactive. Inactive. Now, because Ali exists in the dictionary, it just changes the value from active to inactive. Users, Ali inactive. We can remove from dictionary using del keyword. We can say, for example, delete from users item which starts with the key alley. So users, no alley anymore. We can create a list from the keys in a dictionary. So if you look at the user's dictionary, there is one key here, another key here. We can create a list. If we pass the dictionary to the list, it will create a list using the keys in the dictionary. So look at here, Reza and Sam. Both are keys in the dictionary. We can sort the keys using sorted. So I'm saying users. So it sorts the user's dictionary, but sorts the keys and returns the keys. Reza and Sam. And we can sort in reverse. Sorted users and reverse equals true. So the first is Sam and then Reza. We can check if an item is in the dictionary. For example, we can say Reza in users, which says true. We can also create a dictionary using dict function. We have a function which is dict. What we can do is interesting. We can say Reza, for example, is 42 years old and Ali is 50 years old. If you look at here, we don't put Reza and Ali in a single quote. It's not like this. We don't put it in a single quote. Also, we don't use colon here. We use equals. And look at what happens. Reza 42, Ali 50. It's a dictionary, but Reza goes inside single quote, Ali goes inside single quote, and equals will change to colon. The last way of creating this dictionary is the same thing that we had as a list comprehensions uh, that I talked about it in the list video. We can say, for example, a key of x and the value of x to the power of 2 for x in, we pass a tuple, which is a sequence, 2, 4, 6. So it goes to this sequence, 2, 4, and 6, and assigns the 2 as the key and then to the power of 2 to the value. Look at here. 2 goes to 2 and 4 is a key value. Then 4 comes here, 4 and 16. And then 6 come here, 6 and 36. That's all about dictionary. Now let's talk about range in Python. The range type represents an immutable sequence of numbers. We cannot modify them. When we say immutable, means we cannot modify them. We can create a range like this, range 0 to 10. But we cannot see inside range, but like this. There's a trick. We can create a list of a range so that we can see the range visually. 0 to 9. So range from 0 to 10 starts from here, goes up to this one, but excluding this one. So goes up to 10, but not including 10. 0 to 9. Another one is list, for example, 10, range 10. We don't pass the first argument. So it always assumes that it is 0. Again, it starts from 0. We can say list range of 1 and 11, for example. Where it starts from 1, goes up to 10, because it is excluding 11. And something interesting here. Look at here. I can say list of range from 0, start from 0, go to 30, but do not add one by one. Add 5 on every step. Look at here, 0, and the next one is 5. What we specify here. It goes to 5 and then goes to 10 and then 15. It adds on every step, it adds 5 up to 30. 30 shouldn't be part of it. Now let's look at this one. This is also an interesting. It goes backward. So list of range from 0 go to -10 and decrement one by one. Get here, start from 0, goes up to 9, no 10, 10 is excluded, and on each step it removes 1, reduces 1 from the values. And if you want to create an empty range, we can say range 0. This is an empty range. This is an empty range. Range is a sequence in Python, and as a result, all common sequence operations are applicable here too. I have already talked about these common sequence operations in details in the part 2 of this tutorial, so please watch that first. Here I will only briefly go through them so that you can review it with me. So for example, assume we have t, which is a range of 0 to 20 with the increase of 2 on each step. Well, we can see it like this: 0, 2, 4, 6, 8, 10, up to 18, no 20. We can check if 11 is in T, false. 10 is in T, true, of course. 10 is here. We can check for the index, T dot index of 10. What do you think we will see here? So the index of the 10 is here. So 0, 1, 2, 3, 4, 5. So it should show us the index is 5 here. Yes, correct. Now let's look at the elements at the index of 5, which is 10. Elements start from beginning, go up to 5. It's very interesting. It gives you a range. It says, okay, if you want to go from 0 to 5, this is 0 and this is 5. So it become a range from 0 to 10 with increments of 2 units every time. It's an interesting thing. We can look for the last element. This is 18. If you look at here, this is 18. It's the last element. We can use the check the length of t, which is 10 items in it. We can get the mean of t, 0, max of t, 18, sum of t, 90, and count of number 5. There's no number 5, so it should return 0. Yes. Please note that adding two ranges is not supported. So if we have T1 range and S another range, we cannot do this. Functions are pre-written blocks of code that can be invoked to carry out a certain set of actions. For showing you this lesson, I will use PyCharm. It's easier. So look at the print function, for example. We can call functions, pass some arguments to the functions, and expect them to do something for us. For example, this one, prints hello here. Print here is the name of the function and hello is the argument. In order to tell Python that you would like to create a function, you use the def keyword. After def is the function names. Let's define a function. Def means we want to define a function. For example, do nothing. We don't want to do anything. Then a colon at the end. We come next line. We need to go to the right with four space. One, two, three, four. We can put some documentation here with three double quotes or single quotes. We can put a documentation for the function. This function does nothing. This documentation should always come to the first line after the name of the function. So if this is the function, the first line after opening the function should be the documentation for the function. And this function doesn't do anything, so I will say pass. And because pass is also part of the function, I put it with four space to the right. The indentation is very important. Here, def means we are defining a function. Three double quotes are for writing documentation. And pass means do nothing. In Python, we cannot have empty block of code. So if we don't want to do anything, we have to use pass. We can call it like do nothing, and it does nothing for us. Now let's look at the more interesting function that accepts parameter and does something for us. So let me remove this one. I will say define or def int name. I'll pass two parameters, first name and last name, and colon. Then next line, we want to print this one with the first letter uppercase or capitalized. Want to format it, so I use F. This function accepts two parameters, first name and last name. Let's call it print name, my name and my last name, Reza Ahmadi. I will run it by clicking on this button and then look at here, Reza Ahmadi. So this is the output of the function. We can define parameters with default values in functions. In this case, if nothing is passed for that parameter, then the default value will be used. Let's define a function with a parameter with a default value. So I will remove this, use the same print name, first name, last name. I want to add another parameter, which is a middle name. And I want to give it a default value of empty string. So if you pass a middle value, it will use that middle value. If you don't pass a middle value, it will use the default middle value, which is an empty string. So look at the code. If middle name exists, print all first name, middle name, and last name. What if not? Else. What if not? Then we don't print the middle name. We ignore it. We can copy this one here easily, put it here, and remove the middle name. Here the middle name has a default value of empty string. So if we don't pass any value for the middle name, then the default value, which is the empty string, will be used. Let's call it with passing a value for the middle name and see how it works. Print name, for example, my middle name is ABC. I run it. Look at here, Reza ABC Ahmadi. Now let's call it without passing a value for the middle name. So I will remove the middle name here. This still works. But this time, if you look at here, there is no middle name. If we want to use a parameter with a default value, it should come at the end of the list of the parameters in the function. Here at the end. Any parameter with the default value should come at the end of the list of the parameters in the function. So if I copy this middle name and put it here, it's wrong. It shows the last name as error and it's wrong. We cannot do that. This has to come, must come at the end of it. So this is a good point. When we pass arguments to a function, when we call a function and pass arguments to the function, the order of the values is important. For example, in the print name function, the first value must be first name and the second value must be the last name and the last one has to be the middle name if we define it, if we pass it. But it is possible to call a function without following the order of the parameters. But in this case, we have to pass the name of the parameters too. What I mean is, I need to say, for example, I don't want to keep the order, but I need to specify the parameter. And I say, okay, I want to pass the last name as Ahmadi, and then I want to pass the first name as Reza, and I will pass the, or even let's put the middle name here. Middle name as ABC. Let me run it. Look, here exactly works. Reza, ABC, Ahmadi. The order is not important here. As long as we pass the name of the argument to. In this case, we call these arguments our keyword arguments. Means there is it's like a key value, key value, key value. These are keyword arguments, and we use this term a lot in this video. Now imagine we need a function to get some numbers and print them out. But the problem is we don't know how many numbers the user want to pass. In this case, we can use a specific parameter to accept all of them. Let's remove this and create another function. Define print all. Get here star args. Here star args, the star means any number of arguments. So I will go through the list because it can be a list of numbers. For arg in args, print arg. And let's call it. I can call this one with print all and only pass one. Let's see what happens. It only shows one. I can call 1, 2, 3, shows 1 to 3, or I can say 4, 5, 6, 7, 8, 9. It doesn't matter how many numbers we pass. The function works. So this star means any number of integers. We can do the same thing for keyword arguments so that it accepts any number of keyword arguments. But this time it's a little bit different. For normal arguments, position arguments, there is one star. For keyword arguments, there are two stars. Let me implement this function for you. For key value args.items, so look, this args is a list of key value pairs. Because if you look at that, the keyword argument is like a key value pair, and name of the argument and value for that. So it's a key value. So in here, we have a list of these key values. So with args.items, we get all these key values. Each one, we call it an item. Then we extract the key and value from that item and we show it here. We can call this function like this. Int all Reza active Ali inactive. So what is happening here is we are passing two items here, two keyword arguments. One, two. This one is one item, this is two item. So args.items returns two items. Key and value, which is key and value. We get it and write it. Let's run it. Look at here. Types the key value. So this is how we can access these elements that or items that are passed to this function. Now let's look at another version of this function. This time we don't want to get key values. We are only interested in the keys. So we say def all star star args. The star star means we are interested in keyword arguments. So for key in args dot keys. Keys. So if I want to run this, I can say let's change the name to make it more meaningful. Keys, print keys, and I would say Reza active and Ali inactive. Let's run it. Only show the keys, Reza and Ali. Now let's show the values. So let's remove this one and say define print values. Again, star star double star args. Now this time we say for instead of key we say for value in args that values print value, and we can call it the same as before and it only shows the values. Well, let's make things complicated and interesting. This section is a little bit complicated because it's not intuitive and it's a little bit different comparing to other languages. So let's start it. Basically, in Python, we can define a function like diff standard arc. This is just the name of the function, and we say print arc. Very simple function. Let's see how we can call it. I want to call it using the position argument. I want to say standard arc, for example, 3. Can I run it? Yes, here it's 3. How about if I call it using keyword argument? For example, I say arc equals 3. Does it work? Again, yes. Here is 3. So when we don't do anything, means we are free to call it using position arguments or keyword arguments. But we can make things a little bit difficult. Now, look at this. Define position only arc. Arc and then this magic character forward slash and then print arc. So when we have a parameter and after the parameter is a forward slash, means this parameter, the arc, must be position only. We cannot call it with keyword arguments. For example, I can say position only with 4 and run it and it works. So it's 4. But if I say arg equals 4, then we have a problem. Look at here. Got some positional only arguments passed as keyword arguments. It doesn't accept it, which is a little bit weird. This notation is weird for me. So basically, this makes this one position only. How about keyword only? Do we have something like that? Yes. We can define a function only accepts keywords. Let's define one. Keyword only arc. In here, we should have a star first and then the name of the parameter. In this case, when a star comes first, the parameter which comes after the star has to be called using keyword arguments. So print arg and let's see. So if I call it and say keyboard only and say 5, it is not gonna work. There's an error. I have to say arg equals, we have to call this using uh, keyword arguments. Let me call it. Everything is fine now. To make things even more complicated, we can combine the position and keyword arguments together in a function definition. For example, I can remove this one. I can say define combined example. The first one is position only parameter, so I will pass slash after that. The second one is the standard, don't do anything. And the third one is keyword only, so I pass a star before that. Keyword only. Split all of them. Position only, standard, and keyword only. So how do we call this function? Combine example. The first one has to be position, so I would say 3. The second one, whatever we want, I would say 5, for example. The last one has to be keyword argument. I would say 6. Let's run it. 3, 5, 6. That's it. If you learned it, it was a little bit confusing part. If you learned it, that's very good. Functions can also return values. For example, let me define a function for you guys. Define out any number of nums and a separator with the default value of underline. So let's call it. I will call the print out. I will pass a b. Something that I need to fix it is that here I'm saying nums, but it doesn't have to be number. I'm just saying value or whatever item, because here I'm passing characters. I will call this function. It joins these values together and returns. I will assign the return value into x, then I will print it. So let's see. ABC. So this is the result. In Python, there is a concept of unpacking argument list. Let's look at that with an example. You guys remember that we can always create a list with passing a range and inside the range passing two numbers. So it creates a range for us and it creates a list from that range. Can I say args equal 3 and 6 like this? And 6. Can I say arg equals 3 and 6 and say list range args? Args. Can I pass the 3 and 6 like this to the range? No. If I run it, we will see an error. Let's run it. List object cannot be interpreted as an integer. It sees this one as list. It doesn't accept list. But there is a trick that we can do. We can unpack these arguments. But unpacking means extracting these 3 and 6 from this list and pass them separately, not as a list. Extract them and pass them separately. It's easy. We need just to use a star. So look at that. Worked. So when we say a star, means go to args, find the values inside the args, extract them, and then pass them to the range like this. It's interesting, I guess. Don't be confused by a star here and also a star in the definition of a function. When we use the star in the function definition, means any number of values. It's when we define a function. But when we call a function, not defining, when we call a function, when we pass an argument to the function, this star is for unpacking. We have the same thing for dictionaries. If you remember, we have oops, we have this function, first name, last name, and we print it. We can call this with three different ways. We can say print name, that's all, and we can run it, and it runs without any problem. We can call it with another way. We can call with keyword arguments. We can say Reza equals, sorry, First name equals Reza and last name equals Ahmadi. So in this case, we are passing key value pairs, and it the value of the Reza goes for the first name, the value of the last name goes to the last name. So it also works the same. Look at here, we have two same output. The third one is interesting. I can use unpacking. How? I can say args is a dictionary with first name. His first name is this one, as Reza, and his last name as Ahmadi. Now we can unpack it and pass it to the method. Print name. Now this is keyword argument. So we need to use two stars. Unpack the argument and pass it to the print name. If the third one is also the same output. So look at this tree again, just passing by position only, passing keyword argument as a keyword argument, and the last one creating a dictionary. There are some differences, like here is equals, here is colon, here is not inside the single quote, but here is inside the single quote because it's a dictionary. And then unpack the dictionary and pass it to the print name. It's very interesting. Very interesting. Now let's talk about lambda expressions. Small anonymous functions can be created with the lambda keyword. They are syntactically restricted to a single expression. Let's look at an example, a very simple example. I will create a function which returns a function to me. So instead of returning a number or a string or whatever, this function returns another function to me. So let's say def make incrementor, and I accept the parameter n. And in here we can say lambda simple function gets arg and returns arg plus n. So let's see how we call it. So we pass an n to this function. This function then creates another function, sets the n to this n that we passed, and then we can call this function. For example, I can say my incrementor equals make incrementor on 5. So here we have arg plus 5. Now the 5 that we passed here comes and sits here. So the returned function is like this. It's arg and returns arg plus 5. Now let's run it. This is a function. Why my variable is a function? Why is my variable a function? Because this function returns a function. I call that function, it returns a function. I put the function in here, so this variable is a function. So I would say my incrementor, which is a function, I call it again, and it accepts an argument. So I pass 10. So what does it do? It adds 10 to the 5. So returns 15. I can say x equals this one and then print it to see the results. 15 here. So many languages have this lambda, and it's an advanced concept, I guess. If this is the first time, then please watch this video again and try to write it yourself so that you understand what's happening here. In Python, we can also define the type of the parameters that the function accepts and also the function return type. so that when you look at the function, you understand, okay, it accepts integer, string, what does it return, and things like that. So it's very easy, not complicated at all. For example, define add nums. I want to say, I want to get any number of nums, so star nums. And with column, I will say integer. I'm saying that I only accept integer. Don't pass me anything. And with this symbol, I will say it will return integer too. So don't expect it to return anything else. And I will here say return, for example, sum of these nums. And I can easily say x equals add nums 1, 2, 3, 4, 5, and then I can print x. A module is a file containing Python definitions and statements. The file name is the module name with the suffix .py appended. I have created a module here. The name of the module is printname.py. Let me show you. This is my PyChar, and this is printname.py, which is a normal Python file. And I put a definition of a function which is print full name. We have seen this function before. It gets the first name, last name, and prints it. So here we want to import this module and use this function inside this module. So the way that we use it, we come to the main file that we have, and very easily we import the module by saying import the name of the module, which is print name. That's all. We already imported the module. Now we can call the print full name function inside this module. For doing that, we need to use the name of the module, print name, then dot, and then the name of the function, like so many other languages. So in here we say Reza and Ahmadi, and we can easily run it. Here we have Reza dash Ahmadi, which is our function. The function adds dash here between first name and last name. A module can contain executable statements as well as function definitions. Each module has its own private namespace. Thus, the author of a module can use global variables in the module without worrying about accidental clashes with the user's global variables. Modules can import other modules too. There are different ways to call the print full name function from the print name module. So when we want to work with module, when we want to import modules and functions, there are different ways. There are four different ways that we can import and use functions. The first one is what we see here. We import the module, then we use the name of the module dot the name of the function. Another way is to import the module but assign it to a variable. So we can say import print name as any variable that you want, pn for example. When we do this, then instead of using print name, we can easily use pn instead. So that name that we assigned to the module dot the name of the file, the function, and it works very well. There is another one. In this way, it's a little bit different. We don't import the module, we import a function from a module. So we say from this module, which is print name, import my function, which is print full name. So we say we don't import the module, we say from the module import the file. Because we are importing the file directly, we can easily call the file without the name of the module. So we can say Reza Ahmadi. And let's run it. Yeah, it works very well. And the last way, this which is the fourth way, is we import the function name as anything that we want, as something, for example. Let's make it a better name. For example, print full name, something like this. Now we can use this name as the name of a function because we are importing this function as this name. So we can use that name instead of the function name. It's useful when in our code we have the same function with this name. So we cannot have two functions with the same name. So when we import it as another name so that there is no clashes. Now let's talk about an interesting point. In Python, a module is like any other Python file. You can add executable statements into it in addition to your function definitions. For example, let me remove these things. For example, in here, we have a function definition in our module, but I can add a print hello statement into our module too. So I will say print hello into our module. So this is a function definition. This is an executable statement. So module is like any other Python file. So we can add both of them. These statements, for example, this print, are executed every time we import modules. So let's import this module and see if the print statement is executed. Okay, I'll come here. There's a print statement. I'll come here and I say import my module, which is print name. There is nothing here. We're just importing the module. Let's see what happens if I run it. Look at here, the hello is here. We can see the hello in the output. So it means as soon as we import the module, inside the module, if there is any executable statement, it will be executed. We can also run this module like any other Python file by running the Python print name.py directly. For example, I can come here and say Python print name.py and call it, run it directly. Look, again we can see hello. So there are two ways to run in these statements. One of them is importing this module. Every statement in the module will be executed. Or we run the file, module file, directly using the command line python print name.py. Both of these makes this print statement executed. Now imagine I have some code like the print statement and I only want it to be executed when a user runs the file directly. I don't want it to be executed when the user imports the module. What should I do? So if I put something here, I can run it directly, but when I import it, it also gets executed. But I don't want it. I don't want import to execute this. What can I do? Let me introduce you an interesting variable in Python. The name of the variable is interestingly name. This is the name of the variable. It's a reserved variable that Python works with it. When we run a file directly, the Python interpreter we'll assign this to main string, to main. So when we call this file directly, the value of this variable will be main. But when we import a module, this variable value will be the module name. So let's test it. Let me put a print name variable. First of all, I'm importing this file. So let's see what happens when I import a file. Look at here, that variable, that name variable is equal to the name of the module. But when I run it directly by this, look at here, that name variable is equals to main, because at this time, this is our main code. So this is an interesting point. When we call it directly, name variable will be main. So this is a way that we can use it to distinguish between the situation that our code is running directly or is imported by another piece of code. Let's look how we can use this trick. For example, I have some code which I only want to run it when you run this file directly. So what I can do is just I can add a very simple if block. I can say if name variable equals to main. If name equals to main means the user is calling this file, is running this file directly. So let's print you are running me directly. But when we import it, the name is not equal to main. So this doesn't get printed. Now let's try. First let's import it. Look, nothing happens. Nothing gets executed. Now let's run this directly. Look at here. You are running me directly. So this is an interesting way that you can control if your code is executed inside the import or when the code is executed directly. So you can play with this. We can use open function to work with files in Python. For example, to write to a file, we can say, or to read, let's imagine read. To read from a file, we can say f equals open. I have a file here that I've created. If you look at the test file, it's hello world. I'm here to teach you the Python language. So I'll pass the name of the file to it, which is test file, and then I'll pass the mode. I want to read from this file, so I pass R. R means the file should be opened to read, only read. W means to write to a file, and A means to append to a file. So we want to read from a file. So we open it in a read mode. And in here, we can read all the data in a file using something like the read data equals f dot read. And then printing the data like print read data. And this should be f. The first one, the what is here is called file object. So the open function returns an object which we call file object. from the file object, we can do read and write on the file. So here I'm reading from the file using the read function. And after we are finishing with the function, with what we want to do with the file, we have to close the file with this one, with close function. So let's run it. Look, hello world, I'm here to teach you the Python language. So if we look closely, we can realize that read function reads all the data in a file and returns all of it. And it's interesting that we open it here and we close it here to release the resources. But the question is, what if in between in here an exception happen? So what if exception happens before closing the file? There is another way of opening the file with the keyword with. It closes the file properly even if exception happens. If we open the file with keyword, then we don't need to close it ourselves. It will be closed automatically. Even if exception happens, it is guaranteed to file to be closed properly. So let me show you. Here we'll say with open our test file in a read mode. As if this is a file object. And it's a block of code, so we need this column. And in here we say data equals to f dot read. And we can print it here. Print data. We don't need to close it at all. Right? Everything is here. If, for example, in here on if.read any exception happens, or in print data any exception happens, with will close the file for us. But if you're not using with keyboard, then you should call f.close to close the file and immediately free up any system resources used by it. Now let's look at the different ways to read from a file. We can say f, the file object, dot read to read all the elements and contents of the file. Or we can read a couple of characters, for example, 5 characters of the file. So if I run it, it only says hello, only 5 characters of the file. Or if we want to read a single file, a single line of the file, we can say read line. And it returns the line. One important point about the f.read is that if the end of the file has been reached, f.read will return an empty string. This is something that we need to remember. Now, an interesting point. For reading all lines from a file, you can loop over the file object. It's very interesting. So, for example, I open this file and I have a file object. I can loop through the file object. I can say for line in F. And then I can print the line here. And I don't need to close it here because I opened it using the with. Look, all the lines are here. Hello world, I'm here to teach you and the Python language. We can also read all the lines as a list and loop through that. We can say read lines. This read all the lines returns as a list. Then we can, of course, iterate through the list, loop through the list, and print it out. So this is this one, exactly the same. And another interesting way is to create a list from a file object. We can say list of file object. This when we pass the file object to a list function, it extracts all the lines from the file and puts in a list, and then we can loop through the list. This is also very interesting. To me, it's very interesting way, and it's loop, so we need to add columns. Now let's go to writing to file. So when we wanted to write a file, we need to use the write function of file object. Let's open a file in a write mode. So I will say f, which is the file object, equals to open, for example, um, test test file 2.txt, and this time in a write mode, and we can say x equals to f dot write hello my friend. Okay, here this f dot write writes this sentence into the file, this file, and returns the number of characters written in here in X. So we can check to see how many characters have been written. Print X, and then we have to close the file here because we didn't open it with. So let's check. It says 15. 15 characters be written to the file. I think this sentence is 15 characters. So let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so it means all the statements, all the characters that we wanted are in the file now. So if I open the file here, it is here. Hello, my friend. It is created and it is in the test file to file for us. Now another point. If you have an object X, for example, let me write an if object X object for you. And it's a list. For example, one, two, simple list. You can view its JSON string representation like this. We need to import the JSON module. And here we can say, let's first print X to see how X looks like now. And then result equals JSON dot dumps X. JSON dot dumps gets an object and creates a JSON a string representation of that object. So let's print it. Look, the first line, it's the object itself, but the second line is a string. It's not object anymore. It's a string and it's a JSON representation. So look at here, it's double quotes instead of single quotes. This also has a double quote. So this one is a JSON representation of that object, and it is a string now. It's good because we can use this library to save our object. If we have a complicated object in Python, we can save that object into a file. There is another variant of dumps function. The name of the function is dump here, no s. It just simply serializes the object to a text file. So let's have a look. We need to import JSON, and we need to have the same X. So I will keep it here. And in here, I'll say f equals open test file 2. And we want to write to the file. And here we here say JSON dot dump. What do we want to dump? X, object X, where? To this file. So the second parameter is the file. And we have to close file. So let's run it. And let's open the file, test file 2. Look, this string is here. This is a string and is a JSON representation of that object. We can also read this JSON from the file into our code and work it as an object. Let's have a look. Here we need to import JSON again, and we need to say f equals open our test file 2, and now we want to open it in read mode. And we'll say data equals JSON. Now instead of dump, we want to load it. Load what? Load from file. So it reads an object, one object. We cannot have a list of objects here. One object, if it is stored a complex object in a file, it reads that object and returns to us. So print data and f dot close. We always need to close the file. Get here, this is the object that we have. It's not JSON anymore. I want to talk about exceptions. Let's start with dividing 1 by 0 and run this. It throws the 0 division error and the message is division by 0. So we receive an exception. Now let's look at another way that we can get an exception. For example, let's get an input, integer input from user and test it to see if it is integer or not. So I will say while true, x equals input, please enter a number. This function input gets something in character from the user, but it always returns a string. So we need an integer. So we cast it to integer. We pass it to integer function to get an integer. Now let's run it. Here, please enter a number. I can say 1, 2, 3 in a loop. It always asks for number. What if I enter something which is not a number? For example, R. Another exception. It says value error. This is the exception now. Invalid literal for int with base 10 and what we entered is R. So whenever we do something which is wrong, the code throws an exception. If we enter a non-integer character here, it will throw a value error exception. Now let's put this code in a try block and catch the exception. If we don't catch the exception like here, it breaks the code and exits the application. It exits the program. The program will crash. But we can accept it and handle it. So let's say I can introduce a try block, which you can find in almost all other languages too. So I would say try except. This is for catching the exception. The name of the exception that we are interested in, and in here we handle it. So we will say print, oops, that was not a valid number. So let's run it. Okay, it says integer number. I can say 1, 2, 3. How about R? Look, it doesn't crash. It doesn't come out of the application. We handled it. It shows us a message. Oops, that was not a valid number. And then it goes back to the beginning of the loop and says, please enter a number. So we can add number and continue. As we can see, it doesn't terminate the program and tries to get a number again. A try statement may have more than one except clause. For example, we want to handle different exceptions, not only one exception. We want to handle value error, runtime error, and name error. How do we do that? We easily put the parentheses here and we say, for example, this one, runtime error, name error. So anything that happens which is of this type or this type or this type, we can catch it in here and process it. Now let's create and raise an exception ourselves. For this, let me remove this code. I would say try. We raise an exception using the raise keyword, like throw in other languages. We throw an exception in some other languages. Here we raise an exception. We want to make the exception as type of exception, and we enter, for example, Reza and the second parameter Ahmadi. Now let's catch this using the except keyword. We want to catch the exception. Okay. We want to access the instance that is created, because when we say raise exception with this parameter, it creates an instance of this class, of this exception class. So what we are interested here is to access to that instance. So we'll say accept this exception as something, anything. For example, instance. Inst for instance. So by inst, now we have access to that instance which is being created for us. So first let's check the type. With type, we can check the type of that instance. So for here, we need to print it so that we can see it. Type of the instance. We can also, well, let's run it. The type of the instance is class exception. This is the type, which is true because we created an instance of the exception class. Another thing that we can check is the arguments that we pass to the exception. How can we access the arguments? It's very easy. Let's print it. The way that we access is the instance object dot args. This args returns this args. So let's run it and have a look. Look at here, Reza Ahmadi. These are the arguments of that instance. Now look at the interesting thing. X and Y equals int.args. We are, if you can remember, we have talked about it. We are unpacking the arguments here. So we put the first thing into X and the second one into Y. So easily we can now print X equals, and we can say print Y equals. Let's run it. Look, X is Reza, Y is Ahmadi. So basically args has these two values. We unpack it. We assign the first one to X and the second one to Y, and then we print it. Try except statement has an optional else clause. It is useful for code that must be executed if the try clause doesn't raise an exception. So let's look at this. I will say try x equals 1 divided by 2, which is totally fine. Then I will say and set except zero division error. So what happens if zero division error happens? Then we will print oops. What if exception doesn't happen? What if everything goes very well without any problem? We can say else if everything is fine, then print looks good. So in here, the execution first comes here, this here. If this is fine and there is no error, it comes here. But if it's here and any error happens, this then comes here. So one of these two will be executed, either the except or the else, not both of them. If we want to show something which always, regardless of the error, always is shown, we should come here and say, for example, printer always executed. Okay, so let's trace this code and run it and see what's happening. 1 divided by 2, there's no problem with that. So it comes and jumps to the else, it prints looks good, and then comes out of the try block. This is the try block, and then it reaches print always executed and prints this one. So let's run it. You get here, looks good, which is in the else, and then always executed, which is in here. Now, what if I say 1 divided by 0? This causes an exception. So we jump into the except. Oops, we ignore the else, but it is always executed because it's outside the try. So let's run it. Oops, which is here, ignores this one and then runs this one. It always gets executed because it is outside the try. So this is the else. In other languages, how we handle it, because there are a lot of languages that they don't have else, the concept of else. So if we run something and we want to continue the execution, if everything is fine, we can put this one under this. We don't need else anymore. So if this is executed very well and fine, then we come here. But in Python, there is a specific block for that, which means is everything is good, then come here and run this. If you need to determine whether an exception was raised but don't intend to handle it, a simpler form of the raise statement allows you to re-raise the exception. What I'm trying to say is an exception happens, you want to catch the exception, you want to, for example, log the error, but you don't want to handle it, you want to let it go. So, what we do in this case is this: we say try raise, for example, name error, Reza, except name error. We just want to log it here. Just want to log here. So we say print logging the error. And that's all. We want to let the exception to continue its way through other parts of the system. We don't want to handle it either here. We don't want to stop it here. So we just say raise. By doing the raise, we are rethrowing that exception. So we are here saying just do something with it, but let it go. Just raise it. Let other people, other parts of the code handle it. This is for this one. And let's move on. The try statement has another optional clause which is intended to define cleanup actions that must be executed under all circumstances. And that is finally. So here we can say try, we raise an exception, and we say finally print by world. So it doesn't matter what happens here. If there is an exception, if there is not an exception, whatever happens here, this finally has to be executed before it finishes. So let's run it and see what happens. Look at here, raise exception, exception. So we have really raised the exception here. But at the end, before we finish the code, the finally will be executed again. So look at here, goodbye world. So this is for the operations that has to be done before you finish your program. For example, you have opened a file, you want to close the file. Either everything is successful or there is an error, you want to close the file. Or for example, you have a connection to the database. It doesn't matter if you have an exception or not. If anything goes wrong, you still want to close that connection to the database. So you put all those things that has to happen or have to happen in this block. Now let's look at an interesting example. Guess what is going to happen in the below code, in the code that I'm going to write for you. It's a function, bool return, it returns a boolean. In the try, we return true. And then finally, before we finish this method, we return false. What do you think happens here? If I say print and call the bool return, what do you think we'll see? In try, we are returning true. So normally we should get true. But the finally changes everything. Finally says before anything, the last thing that happens in here is this one. So the last thing that happens is return false. So we see the false. Let's run it. Look at here. It's false. Now let's look at a little bit more complicated one. So we define a function divide, x and y. We have a try here. Result equals x divided by y. We want to catch the exception zero division error. If the zero division error happens, we want to print division by zero. If nothing happened, if everything is successful, we want to say print result is the result. And finally, it doesn't matter if it goes to accept or goes to else. Whatever happens, finally, this should happen. Print executing finally clause. We divide. If everything goes well, we come here and say this is the result and we print this. If anything goes wrong, we show division by zero and then again this finally. Finally is always shown. So let's run it. Divide, for example, 1 and 2. Get here, the result is 0.5 because we don't have any problem, so we come to else, and then finally is executed. But if I say 0, division by 0, the except block gets called, and again the final is happening at the end. Now let's talk about another topic, which is exception groups. In so many other languages that I know, we can only raise or throw one exception at a time. You cannot raise more than one exception or a group of exceptions. But in Python, you can do that. We can raise more than one exception if you want. We just need to add all the exceptions that we want into a group and then raise that group, which is interesting. Let me show you. Let's define a function f and exceptions. For example, this is for exceptions. It's a list. I want to say OS error, which is error 1 as a message, and system error, and as a message, error 2. This is a list of exceptions, and I can raise exception group and pass a message. For example, there were problems and pass this list of errors here and close the parentheses. So in here we can group these two exceptions together. We create an exception group based on these two, and then we raise the whole thing. So we raise two exceptions at the same time. Let's call the function and see how it works. Look at how the exception is printed. It says exception group. This is the message, and it shows the error 1 and error exception 1 and exception 2 here in this nicely formatted text. We can also do one final thing with the exception, and is adding notes to the exceptions. So let me show you by a sample. I can say try. I want to raise an exception. For example, type error. I want to say as a message bad type. I want to catch it, so I will say except type error, and I want to instance exactly the instance of the error which is thrown. I will say as E. I don't want to handle it. I don't want to log it. I don't want to do anything. I just want to add a note here. For example, I want to say E dot add note. I would say, for example, add some information. That's all. And then I would say raise. I rethrow it again. Pass it to the rest of the application. So let's run it. Look at here. There is a type error, which is the message is bad type. And we are not handling it, we are throwing it so we can see the exception on the screen. And here we just added a note, add some information, and the note is here. So for example, you have different parts of the system are calling each other, and an exception suddenly is raised. So different parts get the exception, they don't want to handle it, they just add some information to that and then rethrow it, re-raise it. So at the end, when the main caller gets the exception, it has a lot of information into exception. That's all about exceptions in Python. Today I want to talk about classes. Let's start with the simplest form of a class definition. We say class and the name of the class. That's all. It's the simplest class that we can have. And we can make an instance from it by saying x equals my class. But this class is empty and doesn't have anything. Let's add some documentation. If we want to add documentation to the class, we must put it in the first line of the class. So in here, we can, in the first line, instead of path, we can say three quotes, simple example class. Now let's access the my class documentation using code. We can create an instance, and even we don't need an instance, we can say print class dot doc. So this underline doc underline will give us the documentation of the class. Let's have a look. Look at here. a simple example class, which is this documentation. Now let's add a field to our class and initialize it. I will say here I equals 1, 2, 3, 4, 5. This is a field I, and this 1, 2, 3, 4, 5 is the value. Now let's access the I variable using code. We can say print my class dot I. Get here 1, 2, 3, 4, 5. Now let's add a method to the class. I will say here define a function because methods are normal functions, which are the functions that are part of the class was called method. So print, for example, hello world. Defining a method in a class is the same as defining a function. The only difference is the self parameter that should be passed to methods. This self parameter. This parameter is a reference to this class instance. Let's call the f method by passing the class instance to it. So I will say x equals my class to create an instance of this class, and then I will say my class dot function f method f, and I pass the instance of the class which is self. This x is the instance of this class which goes in and sits here for self. And let's run it. Look, hello world. We are calling the f method now. Please note that we don't need to pass the self parameter explicitly. Python will pass it to the function when we call the method on the instance of the class. So let's create an instance of this class and call the f method using the instance. So instead of this, we can say x dot f. Very easy. So we don't need to call it like this. Run hello world. So we need to call the class, create an instance of the class, and call the method on the instance. And at runtime, Python will pass the instance as the self argument to the method. We don't need to do that. We can assign a method to a variable and call it using that variable. So I can say x equals my class, and I will say, for example, a variable equals x dot f. Look at here, I'm not calling the function, I'm not putting parentheses here. I'm just adding the function, the method in this class, in this instance, and I will assign it to var. How can we call it then? I can call it using this. Now the var is the method. So I can call it like this. It's very interesting. Lots of languages are like this. So x.f, which is the method, we pass it to a variable and then we call the variable. Okay, let me clean this and let's go to another section of this class. The interesting point about classes in Python is that you can place a class definition in an if statement or even inside a function. You can create a class. Now let's talk about the init method. When a class defines an init method, class instantiation automatically invokes init method for the newly created class instance. Let's create a class with the init method and see how it works. I'm creating a class called vehicle, and I will add some documentation here. Some documentation. indentation here, and then I will define the init method, which is this one: underscore underscore init underscore underscore and self. Here I will add a couple of more parameters like color, year, and model. And I will assign these variables on the self object. I will say self dot color equals color. By assigning this color onto the self object, because self is an object class instance, which is an object, I'm assigning this color onto the instance so that I can access it later outside this init method. I will show you what I'm trying to say. So self dot year equals year and self dot model equals model. We can instantiate this class using, for example, v equals vehicle. The first parameter is self for the init. We don't need to pass it. Python will do it for us. We just need to pass the color, which I will say red, year, which let's say 2023, and model, let's say Honda. In this case, the class instance v will be passed to the self parameter here of the init method by Python. The red will be passed to color, the 2023 will be passed to year, and the Honda will be passed to model. When looking at the init method, we realize that it sets all its parameters to the self parameter, which is an instance of the class. Actually, it is setting these values to the instance so that we can access it later. Let's look at it how. So let's add another method. I would say diff get color. I want to access the color, but I'm in another method now. How do I access the color? Well, the color we have already set it on self, and we have self here. So I can say return self dot color. So that's why we need to assign things on the self, because self is something that we have it available in all the methods that we have, and we can access the color in here. So how do we use it? Print v.get color is red. Please note that we can access the color directly from the instance. For example, we even can say print v.color. Why is working? Because self is an instance. We set the color on the instance. So when we have the instance, we have the color on the instance. So we can call it. Some of the interesting points about this language is like, for example, JavaScript, that we can add a field to the instance dynamically. For example, here we don't have a speed, but here I can add the speed and say we did the speed equals to 100. By doing this, we are adding speed to this vehicle object. Or we can delete it. We can delete the speed, which is an interesting syntax for me. So we are deleting a field from an instance using this delete keyword. When we assign the color to the self variable, we are assigning the vehicle color to that instance of the vehicle. Therefore, it is not shared among all instances. Each instance of the vehicle has its own color. Let's have a look. I will clear this. We don't need to get color anymore. And I want to make this simpler. So I will remove year and model. Okay. So let's see how we initialize it. I need a red color, red vehicle. So I will say red vehicle tools vehicle and I'll pass red. And I want another blue vehicle. Tools vehicle, this time blue. Red and blue are passed to this color. So let's print it. Print red vehicle dot color. It should be red, and print blue vehicle dot color, which should be blue. So first one should be red. Red vehicle is red here, and blue vehicle is blue, which is here. So if you look at that, this color is assigned to an instance, not the class. So when we create two different instances, each instance will have its own color. But we can define a variable on the class itself. In this case, it belongs to the class and will be shared by all the instances. For example, I want to come here and say in here a model is Honda. Now I create a red vehicle and blue vehicle and I look at the model of these two cars. Because model is not set on the self, it is inside the class, it will be shared among all the instances. So red and blue all share the same value, which is Honda. Look at here, Honda and Honda. If the same attribute name occurs in both an instance and in a class, then attribute lookup prioritize the instance. For example, let me show you what I'm trying to say. Let's have a class, a very simple vehicle class, and the model is Honda. Now I have my car equals vehicle, so I'm creating a vehicle and print the model of this car. My car, this model should be Honda. Let me run it. My car is Honda. Now, this vehicle class has a variable which is called model. What if I add the same model variable to the instance? What if I come in here and say my car dot model equals, for example, BMW? Look at here. Here I'm creating a vehicle. The vehicle has model inside it. So my car has model. But in here, I'm adding a model to the instance, not the class, to this instance now. And I'll set it BMW. When I want to call the model on the my car instance, there are two models here. One model is for the instance, and one model is for the vehicle. Which one has higher priority? The one which is in the instance. So if there are two variables with the same name, one of them on the instance, the other one in the class, the instance variable is more important. So here we should get BMW. Look at here, BMW. In Python, we can define a function outside the class and then assign it to a variable inside the class to make it a method for that class. It's very interesting. Let's have a look. So basically, Python says if we assign any function to a class, we make a method. So as soon as I assign a function, even if the function is outside the class, as soon as I assign it to a class, then it becomes a method. And we all know that methods need self. So let's create a function. Why I'm saying function? Because it's outside of class. Functions are standalone things. So F1, define function. It has a self, it has X and Y. This is just a simple function which prints the minimum of X and Y. Now we have a class C. We have a variable, but we assign the F1 function to this variable. So this F is now a method. Let's see how we can test it. C equals C. I'm creating an instance of the C class, and I'm saying C.F. I'm calling the F, which is this F1, which is this F1. I don't need to pass the self. I just pass two numbers, like 2 and 5. And it should print the minimum of these two, which is 2. Look at here, it's 2. So basically, we have a definition of the function outside the class, but we are assigning it to a variable inside the class. So we are associating this function to the class. Now it becomes a method. We can work it like a method. We can call it using the instance of the class. Inside the class, methods can call other methods using the self argument. So, for example, imagine we have a class bag and it has an init method. In here, we add a data on the self, which is an empty list. Now we want to have a method called add, and it gets an x, accepts an x, and it says self.data.append x. So there is a bag, it adds the x into our bag. Now there is another function or method because it's inside the class, add twice. It adds this x to the bag but twice. So look at here, it can call the add method using the self variable self dot add x. Let's call it again self dot add x. It's very interesting. You can inside a method, you can call another method using the self. The same that we had access to the color, year, and model using the self, we can access other methods. So in here I can say b equals bag b dot add twice, for example 5, and then print b dot data. Data should be 10 because we are adding, oh, should be 2 5, 1 5 and 2 5 in a list. Yes, 5 and 5. A class method can also access functions and variables that are outside of the class but inside the global scope. For example, let me remove this. Let's say I define a function, print name, first name, last name, and print first name and last name. It's just a function outside of our class. Now the class printer. It has a method which is print me as a self, first name and first name and last name. Inside the print me function method, which I get the first name and last name, inside this I want to call this one, this function outside. I have access because this one is part of, it's outside any class, it's part of the global scope. So I can say print name and I pass the first name and last name to that. Let's have a look. P equals printer. Now p dot print me. I'll pass Reza Ahmadi. I'll call this one. It comes in here. It calls this one, and this one prints my name. Look at here, Reza Ahmadi. Now let's talk a little about inheritance. Let's assume that we have a vehicle class with color and speed variables. So class vehicle, I always make a problem here. F init, color and speed. Self dot color equals color. Self dot speed equals speed. And we have another method, def print info. Itself, what it does, it just says print format color self dot color speed self dot speed. We can now create a vehicle and print its info. So we'll say v equals vehicle. I pass red and 200 as the speed. I will say v dot print no, v dot print info. Let's have a look. So color red, speed 200. Beautiful. Now imagine we need a subclass of the vehicle class for our Honda cars. We can create the Honda class and extend the vehicle. So get rid of these two. Here I will say class Honda. I want to extend vehicle. So I put the vehicle inside the parentheses. So this vehicle is a base class or super class. This Honda is a subclass. Honda inherits or extends the vehicle. In here, I want to have my own initializer. Here, I want to get color, I want to get speed, and I want to get year. Now, at the beginning of this init, I want to call this init from my superclass and pass these two to that instead of manage it myself. So I will case super, we call a super, it's like a function or method, and then we say init, pass the color and speed. So what happens is when we create a Honda object instance, we know that it calls this method first. But this method also goes to the super, which is vehicle, and calls the method first. Passes the color to this color and this speed to this speed. But how about year? We don't have year in the vehicle, so it should set it on itself. Self the year equals year. Year is something which is only relevant inside our Honda vehicle. Our vehicle doesn't have it. Only Honda has it. Because we have this year, we need to also change the print info and add year to this. So come here, print info, and we can say year self.year. Interesting thing here, if you look at that, is when we pass color and speed into super, we again access it using self. So in some languages we access it using super, but in here we access it using self because we are inheriting those variables, and the variables are part of the Honda. So I'm calling the super. I pass the color and speed on the super, which is this vehicle. It says on the self, but it down in the print info, I can access it using self. There is no difference between year that we set it ourselves and the speed and color. Okay, so let's create an instance and see what happens. I can say H equals Honda, the red Honda, 100 speed and year 2023, and H dot print H dot print info. So when we call print info, because we have two print infos, one in the parent class, one in the child class, the one, because they're the same, this overrides this one. And when we call it on Honda, the one which exists on Honda gets called. So we see the year in here too. This is year. The one on the parent doesn't have a year. We don't call that one. This one gets called, which is here. But if you remove this, then the parent one, which is inherited, will be used. Let's try it. I will comment this one. So we don't have print info in our Honda class. We only have print info in the vehicle. Now, because this one is inherited, now if I run it, you don't see the year. See, you're calling the parent one, this one. But with having the same function and method in our class, the this one, which is inside the Honda, will be called. Sometimes, let's talk about something else. So sometimes it's useful to have a data type similar to the Pascal record or C struct, bundling together a few named data items. This is how we do it in Python. We need first import data classes from from data classes module. We want to import data class, and we say, for example, we have a class employee. Here we have a name of type a string. We have a department of type a string, and we have a salary of type integer. What we need to do is on here we should add data class. See what happens when we say data class. When we say data class, this becomes a structure which bundles these things together. So let's create an instance and see how it works. I can say here, down here, I can say Reza is an employee. My name is Reza. My department is computer lab, and my salary is 1,000. And look, I can say print Reza the name, print Reza the department, and print Reza the salary. Let's have a look. So what it does here, look at here, Reza Computer Lab in 1000. So what is happening here is we don't need to create the init method anymore and pass this to the self and all these things. Using this data class, it does all these things for us. We just need to say which fields we need, and it creates for us the init method, adds all these things to self so that we can use it here. I want to talk about enumerations in Python. For creating an enum or enum, we need to first import the enum class and then extend it. So let's import from enum, import enum. Now say class, for example, vehicle based on enum. Benz, for example, one, BMW, two, Honda, three. These are our enums. Now let's print some vehicle values. Let's say print, for example, vehicle dot ends, and let's run it. So vehicle dot bends, if we print it, is vehicle dot bends. It's okay. Now let's look at the type of the vehicle dot bends. So we get the type by the type function. Type of vehicle dot bends. What is the type? It's enum and it's vehicle. Now look at the representation of the bends. We have a function to getting the representation of a class, which is rep r, and we say vehicle dot bends. And this is the representation of the class. It's vehicle of type vehicle. It is the bends, and the value is 1. Rep r or representation normally is used to get a string representation of the class with enough information so that we can recreate that class from this information. So here we are saying it's vehicle, so we know that enum is vehicle. This item is bends, and the value is 1. So it gives us enough information. For example, it's useful for debugging so that we know what we are working with and what should we do. So these are three print document methods. Enums have names and value properties. For example, I can print I can print vehicle that bends, which is the enum. That's name because each enum has a name and has a value. So this is the name, and the second one is the value. So it shows that the first one is the name, which is Benz. So Benz is the name of this enum, and the value is 1. Enum names must be unique, but the values can be duplicated. We cannot have another Benz in here, or BMW or Honda. We cannot do that. But we can have something like, for example, Kia. We can assign it again 3. It's okay to have duplicated values. For example, that value of Kia is 3 and value of Honda is 3. It is okay. But we cannot have duplicated names. But we can prevent duplicated values by using unique. If you don't want to have duplicated values, you can have use a unique. So we can from enum we can import enum and unique, and then on top of this we can say unique. When we add the unique on top, then it controls the value of our enum so that these values are also not duplicated. When values are not important, we can use auto to auto assign the values. So let me get the auto, and in here we can say Kia, for example, auto. It is auto assigned. Let's check it. Let's say print vehicle dot value, for example. The value is 4. It is auto generated. We didn't assign it. We can also use enums as hash values in the dictionaries, in the lists, in the places that we need hashes. For example, let's have a dictionary here. I would say my cars is an empty dictionary, and I will say my cars vehicle dot Benz. For example, the price is 100,000. 100,000. And we can print it. Print my cars vehicle dot Benz. 100,000. I want to talk about weird methods in Python classes. So let's create a vehicle class with init method. I add two properties, color and model parameters. We already know that every time we create an instance of this class, the init method is called and it sets the color and model on the instance. Well, we can control the setting operation. Every time that we assign a value on the instance of a class, the setAttr method will be called, and we can implement this method to control the assign operation. Let me show you. We need to define the method setAttr. In here, we say print setting this key to this value so that we can trace it and see if this method is called. And then I will say super, and I call the setAttr super method, and I will pass this key and value to the parent class. So let's create an instance of this vehicle and see what happens. I will come here and I will say v equals vehicle red and Honda. And let's run. So if you look at here, when we create this object, We want to set the color and set the model. Each time that you want to set anything on the object, if there is this method will be called. So here we are assigning color and model, two assignments, and the method is called twice. The first time setting color to reg, the second time setting model to Honda. And if you notice here, we call the super.setAttr method so that the values can be set on the instance. If we remove this line, then nothing really happens, and as a result, the values won't be assigned. So if we remove it, then nothing happens. But if we implement this method, every time that assignment happens on the instance, then this method will be called. In the same way, we can also control the retrieval of attributes by implementing the getAttr method. It gets called every time we retrieve an attribute. Let me show you. And the interesting thing about this getAttr is if the value that we want, if the attribute that we want is already exists on the object, it goes and gets without calling this method. But if the attribute doesn't exist on the instance, then it looks for this method. So for example, in here, I would say, let's put a print line to get some information, getting vehicle item. And in here, I would say if the item which is asked for, if it's info, for example, then return self.color and self.model. It's a tuple. Okay. Let me show you, it's easier when we see how it works. I will create an instance of the method and I will say print v.color. If I run it, it doesn't come into this method. We don't see this line. Have a look. To setting colors, that's fine. And it says red. It should be red, not red. So the color is red. It doesn't come to this method because it can find the color on the object. So in the same way, if I say print b.model, again it prints Honda. It doesn't come in here because it finds the model on the object. What if we say print, for example, info? v.info. The info doesn't exist on the instance, so it's not here. So the Python comes and runs this method to see if we are handling this information, and we are handling. So let's see what happens. This method is called getting vehicle info. It shows that this method is called, and because the item is info, it returns self.color, self.model. This is a tuple, red and Honda. So again, if a property exists on the instance, then it doesn't read this function. But if it doesn't exist, it reads this, it calls this function in this method to see if we are handling it. What if we want to print something which we are not handling it anywhere? For example, print v.speed. So what happens is for the last one, let me comment these three. For the last one, for the speed, it comes here on the self. Speed is not here. Speed is not here. Then it comes to get ATTR. There is no code for a speed. We are handling info, but there is no code for a speed. So let's see what happens. None. Here the print statement says that getting vehicle speed, getting vehicle item. So this item right now is a speed. This item is a speed. Are we handling a speed? No. So none is the result. We can also control the deletion of an attribute by implementing the del attr method. So let's have a look. Let me remove this part. Okay, we'll say if item equals color, print cannot delete color. We don't want to let the color to be deleted. So we will say cannot delete color and we don't do anything. But if it's not color, else we say print removing, for example, attribute, and then which we know it is model. So removing model, and in here we call the super to finish the work. We call the deleted here from super and we say please delete the item for us. So here I'm calling vehicle, I'm creating vehicle, and I will say let's delete from the vehicle the color. And let's print vehicle dot color. Okay. So if you look at here, when you want to delete a property or attribute or field, it always comes and calls this method and passes that property as the item. So we check if the item is color, we just print cannot delete color and we don't do anything. So the color won't be deleted. And when we print it again, it prints it without any problem. Let's have a look. Cannot delete color. This comes from this line. And then when we print color, color is there, still there. So color is red. How about removing something else, the model, for example? Delete v.model and then print v.model. So this time it comes in here, executes this code. It's not color, it's model, so it comes here. It says removing, passes the model to the super, and everything is fine. So we don't have model anymore. So let's have a look. Removing model and none. The reason that it says getting vehicle model is because it goes in here. It goes in here. Why it comes in here? Because we remove the model doesn't exist anymore. So it comes in here, it doesn't find the model on the self because we have removed it. So it comes in here, says, okay, look it for me. And it says getting vehicle model and doesn't find anything. So returns none. There is the dir function which lists all the instance attributes. We can control it by implementing the dir method. Let me show you. Let me remove these lines and implement define dir. It's very nice when we want to see what's happening inside a class, to see all the attributes inside the class. For your own class, you need to implement it. So here I will add a comment, list of available properties. What properties here we have? Return, color, One model is another one that we have, and we also support info. We also support info here in get attr. We also support info. So we are saying we support these three infos. So let's test it. I will come in here. For example, I'm working with vehicle class and object. I want to see what properties, what attributes do I have. I can work with, and which one exists here, and which one I can call. So I will say print dir v. This dir, when we pass an instance, it calls this method on the instance. So let's have a look. Color info model. Now let's print the vehicle instance and see what happens. We have printed different properties of the vehicle, but let's print the vehicle. Let's see what happens. Main dot vehicle object at a weird number here. This is normally the address of the memory. So this is not very helpful. So we can control the string representation of our class object by implementing the str method. So there is another method here. We can say def str, and in here we can return whatever we want to be shown to the user. For example, return f. This is a self.color, self.model car. Now let's run print v. It should return this for us. This is a red Honda car. Look at here. This is a color red, model Honda, and car. This is a red Honda car. This is much informative. It's meaningful. It's useful. So we can also do that with our classes by implementing the str. Now let's look at some other interesting methods. Let me remove this class. So we have init, set attr, get attr, del attr, and dir and str. But we are all done with this. We want to explore more interesting methods. Let's create a Lego box class. So class Lego box. And let's initialize it. Diff init. And let's imagine there's only one property, and that is pieces. Number of pieces that exist in this Lego box. Pieces. Set it on the self. Pieces equals pieces. That's all. So let's create an instance and print it. Okay. Lego box 1 equals Lego box with 100 pieces. Let's print it. Again, a very weird information which is not useful. So let's implement the str method to get more meaningful result. So in here, I would say def str, then return f Lego box with self.pieces. Now read it to see what's happening. Much better output. Lego box with 100 pieces. Let's create another Lego box with 200 pieces now. Lego box 2 equals Lego box with 200 pieces. And let's print it. So the first one is Lego box with 100 pieces. This one is Lego box with 200 pieces. Now a question. Can we add these two Lego boxes together? No. If we want to be able to add two instances of the Lego box class together, we need to implement the ADD or add method. Let me show you. So I will close this one and I will here define add. I will say return a new Lego box with the first one pieces plus the other one, the pieces of the other one. So the self is the first one, the second one is the other. So I will say if two objects of Lego box are added together, create a new Lego box, add the pieces of the first one with the pieces of the second one. Let's try it. What if I say Lego box 3 equals Lego box 1 please plus Lego box 2? Let's print it. This one has 100 pieces. This one has 200 pieces. So it should have 300. Yes, Lego box with 300 pieces. So this is how we handle adding two instances of our class. How about subtraction? In this case, we need to implement the sub method so that we can subtract the instances of our class. So def sub return a new Lego box self dot pieces minus the other dot pieces. So let's test it. Now let's remove this part and say Lego box 3 equals Lego box 2, which is 200, minus Lego box 1, which is 100. So the result should be 100. This is 200, this is 100. The result should be 200 minus 100, 100. Lego box with 100 pieces. There is another addition in Python which is called in-place addition. We can implement it by implementing the I-add. In this case, the first Lego box pieces will be updated. We don't create a new box. If you get here in the add, we don't touch the first one, we don't touch the second one. We are creating a new Lego box. But with I-add or internal add, or in place add, we are not creating a new Lego box. We change the number of pieces in the first Lego box. So let's have a look. Define I add, and in here self dot pieces plus equals other dot pieces, and then we return self. So let's see how we use it. And in here, I would say Lego box 1 plus equals Lego box 2. This is in place addition. And let's print Lego box 1. And also before this operation, let's print Lego box 1. So in here, Lego box 1 should have 100 pieces. After this addition, should have 300 pieces. Lego box 100 pieces, Lego box 300 pieces. But this time, we don't create another Lego box. We update the first Lego box with the new value. There are also some cool methods for comparing the class instances. For example, if an instance is greater than the another one, or less than, or equal. So for greater than, we need to implement the GT method for greater than. Let's have a look. Define greater than. Say return if self dot pieces is more than other dot pieces. Or less than. Let's define all of them. Less than is this one. This time return if this one, the pieces, is less than other the pieces. And also equal. If two objects, when two objects are equals, this is something that we need to implement it. The Python doesn't know. We say, okay, for checking the equality, we need to check the pieces. So the self the pieces should be exactly the same as the other pieces. If these two are the same, then we say yes, these two objects are equal. If the first one is less than the other one, we say it's less than or it's greater than. So let's try them. Print Lego box 1, print Lego box 2. Oh my god. And then here, the interesting part. Lego box 1 is less than Lego box 2. Lego box 1 is 100. Lego box 2 is 200. So Lego box 1 is less than Lego box 2. So it should be true. It is true. How about equal? Are they equal? Print Lego box 1 equals Lego box 2. Well, when we say equals, it comes and runs this method. It says, are the pieces equal? No, the pieces are not the same. So it returns false. Returns false. But for the first one, it is a less than. So it calls this one LT. It's very cool, isn't it? So calls this one and checks the pieces are less than the other one and say true. I really like this uh, functionality and availability in of these methods in Python because uh, we can't have something like this in some other languages. Like for example, in Java, you can't overload this less than or equal than like this. You need to implement it in another way. Thank you for watching and see you later.